In the last video, we talked about linear transformations of a single random variable, and in this video we're going to talk about how we can combine multiple random variables. So we're going to do this by looking at an example. We're actually going to keep with the same example we started working with in the last video, where we've got this Jeep company, Pete's Jeep Tours, and he takes tourists around in his Jeep for a certain fee. And so Pete's sister Erin, let's say that she notices that he's having quite a bit of success with his business, so she decides that she wants to join in, and she's also going to offer tours in her own Jeep, but however her Jeep is slightly smaller than her brother's, so she can only hold up to 5 passengers. And after some time, she's able to develop a probability distribution of the number of passengers she can expect to get on a given day, just like Pete was able to, and that probability distribution is what you see on this slide. Just like Pete, she requires to have at least 2 people to have a tour go forward, and like I just said, she can carry up to 5 people in her vehicle. And then the associated probabilities for each of those values for y are given in the probability distribution. So again, we are calling x the random variable for the number of passengers that Pete has on his tour on a given day, and we're going to call y the number of passengers that Erin has on her tour on a given day. So of course, since we have the probability distribution, we can calculate the mean value for y and the variance and the standard deviation. In this case, our mean value is 3.1, and our standard deviation is 0.943. Now, let's say that Pete and Erin want to figure out what their average number of passengers is for the two of them, not just for each one individually, which is what we've calculated so far. So that means that we're going to have some new random variable, we'll call it t, and that's going to be the total number of passengers for both Pete and Erin. Well, then that means that t is equal to x, the number of passengers that Pete has, plus y, the number of passengers that Erin has. So then to calculate the mean of t, the average number of total passengers they can expect to have, we could come up with the probability distribution of all the different values, and we could come up with all of the associated probabilities for each of those possible outcomes, and then calculate our mean that way. But it's actually much easier than that. All we need to do is add together the mean of x and the mean of y, which probably makes some sense. If we want to figure out the average total number of passengers that they have on a given day, that's just going to be equal to the average number of passengers that Pete has plus the average number of passengers that Erin has. To calculate the variance of this situation, it's the exact same idea. We would calculate the variance of each of our individual random variables, which we've already done, the variance of x, and then we would just add that on to the variance of y. And just by adding those two values together, we can get the variance for our combined random variable t. Now that is important to keep in mind. We add the means to combine random variables, and we add the variances. So these are two relationships that you need to be familiar with. You cannot ever do not add standard deviations. It won't work out. And if you're not convinced of that, you could just give it a try with the standard deviations where you've been given for x and y and see how that works out. You won't get the correct standard deviation if you just add the two standard deviations individually. In order to get the standard deviation for t, you would have to first calculate the variance for t, which you simply do by calculating the two individual variances and then taking the square root of that value. Let's say that instead of wanting to know the total number of passengers for their two vehicles, Instead, Pete and Aaron want to know the difference, so we'll call that x, the average difference in their number of passengers. So that means if we want to find E of s, then in this case we're just going to subtract the average for both of our individual random variables. That's not too surprising. What is a little bit tricky, and you have to keep in mind, is that when you want to calculate the variance of the difference of two random variables, it actually doesn't make any difference that you're subtracting instead of adding like we were before. You still just add the two variances together. And just like before, you do not want to add the standard deviations of your two random variables. You only add the variances and then take the square root of that value that you get to find your standard deviation of the combined random variable.